In this problem, we need to find the exact solutions of this logarithmic equation here. When you're looking at logarithmic equations, it's important to determine if every single term is a logarithmic term or is the some term that is not. So looking on the left-hand side, both of these terms are logarithmic terms, and the same on the right-hand side. So what I'm going to do in this problem is my goal is to combine these two terms into one logarithmic term, these two terms into one logarithmic term, and then I want to use the one-to-one property of logarithms. So the first thing I have to do is combine these two terms here. When we combine logarithmic terms, we need to make sure that coefficients are either ones or negative ones. This is a 1, this is a negative 1. So that's good. So now we look at these two terms. I have the difference of two logarithmic terms. So out of these properties of logarithms, I'm going to use the last one that says the difference of two logarithmic terms becomes the log of a quotient. So the left-hand side is going to become log to the base 4 of a quotient. And which argument do you put in the numerator, which in the denominator? So the log that has a plus 1 in front of it, its argument goes in the numerator. The log that is negative, its argument goes in the denominator. So in my case, x minus 1 is going to go in the numerator. X plus 6 is going to go in the denominator. So that is taken care of the left-hand side. And now on the right-hand side, I have the difference of two logs again. So I'm going to combine those, and it's going to be log to the base 4 of another quotient. And who goes in the numerator? The log that is positive has an argument of x minus 2, and x plus 3 is going to go in the denominator. So now I have one logarithm on the left and one on the right. I have a coefficient of positive 1 in front of both of the logarithms, and the bases are the same. The one-to-one property of logarithms says log to the base b of a quantity. If it equals log to the base b of another quantity, those two quantities have to be equal. So using the one-to-one property of logarithms, all I do is set both arguments equal to each other. And now I have an algebraic equation. This is a rational equation, so I need to find the least common denominator. So I look at my first denominator, I need an x plus 6 in my LCD. Now I go to my second denominator. Do I have an x plus 3 there? No, so I have to multiply by x plus 3. And now all I have to do is multiply both sides of this equation by the LCD. So there I've multiplied the left-hand side, and now I'm going to do exactly the same on the right-hand side. And by multiplying both sides by the LCD, hopefully all my denominators reduce away. X plus 6 goes with x plus 6. X plus 3 reduces with x plus 3. So on the left-hand side, I'm left with x plus 3 times x minus 1. Equals on the right-hand side x minus 2 times x plus 6. So now we have to FOIL this out. So on the left-hand side, first x times x is x squared, negative x, and plus 3x and minus 3. Remember, FOIL. First, outer, inner, last. Do exactly the same on this side. And what do I get? I get x squared plus 6x minus 2x minus 12. It looks like a quadratic equation since I have x squared and an x squared, but if you notice, if I subtract x squared from both sides, my x squareds totally reduce away and I get negative x plus 3x. I think I can combine those. I'm going to get 2x minus 3 equals 6x minus 2x is 4x minus 12. So I have a nice little linear equation. And let's get all my x's on the right-hand side. And I'm running out of room, so I need to go to the next slide. So this is where I got to on the previous slide. Negative 3 equals 2x minus 12. So I need to add 12 to both sides. And negative 3 plus 12 is 9 equals 2x. And then divide both sides by 2, so I get x equals 9 over 2. And are we done yet? No, because this was a logarithmic equation, we must check for extraneous solutions. That means we go back to the original equation we were given, we take our solution and plug it in for every x in the original equation. And what we're checking to make sure is that each argument of every single logarithm is a positive number. Because remember, the domain of a logarithmic function is all positive numbers. So we're going to have to check our solution of x equals 9/2. And it's a little bit easier to check if you take 9 divided by 2 and get 4.5. So let's check all our arguments. Log to the base 4 of 4.5 minus 1. Is that a positive number? Yes, good. Minus log to the base 4 of 4.5 plus 6. Is that positive? Yes. So far, so good. Equals log to the base 4 of 4.5 minus 2. Is that positive? Yes. Minus log to the base 4, I'm running out of room, 4.5 plus 3. Is that a positive number? Yes. So we have just proved that this answer is not extraneous. We haven't proved it's totally correct. To do that, we'd have to complete the checking process, but all you have to do is make sure your solution is not extraneous.